So guys, till now we have discussed about the wave nature of the EM waves and the electromagnetic spectrum. Let's talk about the particle nature of EM waves, which was given by Max Planck in 1901. Now history says that the failure of the classical electromagnetic theory of the radiation to explain the phenomena of photoelectric effect means the wave theory was not able to explain the phenomena of photoelectric effect. If we want to eject out the photoelectrons from some metal surface, the wave should have some mass, which is not possible. To explain this, a theory is given by Max Planck, and this theory is called Planck's quantum theory. Let us see which points he emphasized. The first point was the radiant energy is emitted or absorbed not continuously but discontinuously. It means that whenever energy is emitted, it will not come out continuously, it will come out discontinuously in discrete fashion, in the form of the small packets that are called quanta, and you also call them photons. It means that the energy will come out in the forms of quanta or photons, like 1 photon, 2 photon, 3 photons, 4 photons, like this. 1.5 photon will not come out. It means that we cannot cut the photon. The second point, he said, the amount of energy is directly proportional to the frequency of the particular radiation. That means E, that is energy of that particular radiation, is directly proportional to frequency, and it is equal to h nu, where h is the Planck's constant and its value is 6.626 into 10 to the power minus 34 joules second. So this was the second postulate given by Planck. Third postulate that was given by Planck, that if the light is emitted or it is absorbed, it will only in the terms of integral multiple of the quantum. That is, E is equal to n h nu. Now E is the energy, n is a natural number, h is Planck's constant. It means that energy will be always integral multiple of h nu. Means we discussed earlier, either 1 electron will come out, 2 electrons will come out, 10 electrons will come out, and the energy will be 1 into h nu, 2 into h nu, 10 into h nu, 100 into h nu, but it cannot be 5.55 into h nu or 8.5 into h nu. Again he is saying either energy is emitted or it is absorbed. It will be the integral multiple of the quantum. We cannot cut the photon, right? And the value of n is 1, 2, 3, 4 and so on. Now, this Planck's quantum theory explained the photoelectric effect. Let's see how. Explanation of photoelectric effect. Now the same diagram we studied there, that was the limitation of wave theory. Now you can see here, light is coming, it is striking to the metal surface, electron is coming out, and if electron is coming out in this way, the current will flow in the different direction and we will get a deflection in emitter. That is for sure. Now let us assume the energy of the radiation is E. So E is the energy of the radiation and E naught is the minimum energy required to eject out the electron from the metal surface. So what is E naught? E naught is the threshold energy, and threshold energy is the minimum amount of energy required to eject out the electron from the metal surface. Now, if energy of radiation is smaller than the threshold energy, electron will not come out. But if energy of the radiation is more than that of the threshold energy, electron will come out and the rest of the energy will become its kinetic energy. That is, E minus E naught is equal to kinetic energy. And you can see that when light will come, strike to the metal surface, electron will come out, and if electron is coming out in this direction, current will flow in the opposite direction. So this is called the photoelectric effect, right? If we study it further, we can say that E minus E naught is equal to the kinetic energy of that photoelectron, and E is the energy of radiation. E naught is threshold energy, and in books you will find that the threshold energy is also called work function. He will give you this much is the work function and this much is the energy of the radiation. Find the kinetic energy. We will solve the numericals on this theory in the next lecture. Now, if we find the kinetic energy from here, the kinetic energy will be E minus E naught. Now, E is equal to h nu according to the Planck's quantum theory. Therefore, the kinetic energy is equal to h nu minus h nu naught, and nu naught is threshold frequency. And we everybody know that nu is frequency and frequency is c upon lambda. Therefore, we can also write E is equal to hc by lambda minus hc by lambda naught. So we have three different formulas, and the formulae are: first is this one. Now this is on the basis of energy. Second is this one based on frequency, and third is this one based on wavelength. Now these three formulas you have to keep in mind, right? Let's see graph associated with this theory. Now the first graph is between the kinetic energy and the frequency. Now we all know that nu naught is the threshold frequency. If the frequency of the radiation which are falling on the metal surface is less than that nu naught, electron will not come out. So if the value of the frequency is here, electron will not come out. If we increase up to here, again it will not come out. Up to here, again it will not come out. If we give it just more than threshold frequency, it will definitely come out and it will have some kinetic energy. And if we keep on increasing the value of the frequency of the radiation, then kinetic energy will also increase. So the graph between the frequency and the kinetic energy is this. Let's move on to the next graph. Now this graph is between the kinetic energy and the intensity. Intensity means you are radiating more number of photons. If you are radiating more number of photons, more number of electrons will come out. But you are not increasing the energy of a particular photon. That is again E is equal to h nu. We are not changing the frequency. If we are not changing the frequency, energy will not change. If energy will not change, then kinetic energy will not change. That's why we have a straight line here in this case. So intensity, if you increase the intensity, nothing will happen to kinetic energy. But yes, if you increase the intensity, the number of photons will increase, the number of quanta will increase, they will increase the number of photoelectrons, and that is our next graph. Number of photoelectrons versus intensity. And if you increase the intensity, you can see that number of photoelectrons will also increase. So that was the theory and the graph of photoelectric effect, and that's how the Planck's quantum theory help us to prove that the electromagnetic radiation also have the particle nature. So this is the end of the lecture, and I hope that what I have taught you, you have understood each and everything very well. We will meet soon in the next lecture. Till then, goodbye.